You may have noticed that really all we've done with these collections is iterate through them. And we looked a handful of things up in the map. But in general, you may want to sort your collections and you may want to go and find elements in your collections, even if they're not maps. If you look for these as member functions of, say, vector or list, you won't find them. They are external functions that take a collection. Actually, most of them take a pair of iterators so that you can search through just from here to the end of the collection or from the beginning to here of the collection. And the special case of from the beginning to the end, you just take by passing in the begin and end iterators. You use the same functions, whether you're searching over a vector, a list, a queue, doesn't matter. That way you don't have to think as much or even change your code as much if you change the collection that you're choosing to use to keep your stuff in. One of the really important ones is for each. We were using language fors to loop through with our iterators, but there's a for each I'll show you, and a find and a find if. Find tries to find a particular value in a collection. Find if finds values that meet a particular criteria, such as being less than 100. There are far too many to list. The good thing to know is that they are there. Just looking for them as member functions of the collections, not finding them, you might think they don't exist. They do. They're in a header, by the way, called algorithm. So you include the particular collection that you're going to use, vector, map, queue, whatever, and then you include the algorithm header and you gain the ability to search or to sort. Thinking this way puts you in a good position to make certain other changes in your application super easy. One example, if you use the standard for each instead of the language for, then you can switch out the for each for a, say, concurrency parallel for, and ta-da, your application, at least that part of it, is parallelized. In the concurrency namespace, there are, depending on which header you include, a selection of PPL, Parallel Patterns Library functions that parallelize across multiple CPUs, or in the AMP, Accelerated Massive Parallelism, there are a collection of parallel fors that parallelize across the GPU. Now, it may seem impossible that you could make such a localized change in your application and actually gain the benefits of concurrency that quickly, but that's exactly what using library functions can bring you. Now, the disadvantage of using this approach is it creates tiny little functions, I'll show you them in the demos, that you need to pass in as arguments to find if or for each. Call this function on every element in the collection, or find elements of the collection for which this function returns true. A nice way around that, which we'll get to in a later module of this course, is to use lambdas. So if this looks a little ugly for now, just keep in the back of your mind that it will get less ugly once you can use lambdas. But let me show it to you the useful but a little awkward way that it is without lambdas first.